In today's video, I want to explain the laws of exponents, and I'm more specifically going to focus on the rule of a power to a power. This video is dedicated to grade 10 maths students. I'm just going to quickly do a rundown on what powers, exponents, and bases are. So this whole thing here is called a power, and the different components. This part here on top is called an exponent, and the part at the bottom, this part here, is referred to as a base, and the whole thing is called a power. Before I dive into the examples, which are mixed problems where you apply different types of laws of exponents, there's a few crucial and important laws of exponents that I need to discuss. For example, let's say we have the following exponent. Let's say we have 2x raised to the power of 2. This law of exponent is called power raised to the power. In other words, whatever powers inside the bracket, in this case 2 to the power of 1 and x to the power of 1, whatever's inside should be raised to the exponent on the outside. And how we do this is we multiply. So in other words, this should be 2 to the power of 1 multiplied by 2 and x 1 times 2. So this is 2 to the power of 2 and x to the power of 2, which is 4 times x to the power of 2, which is 4x squared. The second important law of exponents is if you have something with a negative exponent, for example x to the power of negative 5, the important aspect of this is that you should never write an exponent a power with a negative exponent. So as a rule of thumb, you should always write it as a positive power. So what I normally do is I write this as a fraction. Anything over 1, any number or variable over 1 is that number. So what happens is if you interchange the numerator and the denominator, the exponent becomes positive. In other words, if you interchange these two, put the numerator in the denominator and the denominator by the numerator, the exponent automatically becomes positive. So this can be rewritten as 1x to the power of 5. So this is a very important law of exponent. Whenever you have a negative exponent, write it as a fraction, like what I did here, and then interchange the numerator and the denominator, and then the exponent will become positive. And lastly, any exponent, whether it's 8 to the power of 0, any power to the exponent of 0 is 1. Any variable or number to the power of 0 is 1. This here is also a very crucial law of exponent. Whether it be a variable, whether it be a number, any number or variable to the power of 0 is 1. So let's look at the examples. These are mixed problems where you apply different laws of exponents. So when you look at the first example or the first problem, already we can see the exponent is negative. So what you need to do here is you need to write this power with a positive exponent. So we can say this is equals to 2 x to the power of negative 5 right? So what you can do is you can write this as 2x to the power of 5. Remember, if you interchange the numerator and the denominator, the exponent becomes positive, right? So let's have a look at the second one. The second one is raised to the power. So whatever term or number or variable inside the bracket, you need to raise to the power of -5. So what I normally do is I write the exponents, and then whatever exponent is inside, you just multiply with that on the outside. So this can be written as 2 to the power of 1 multiplied by -5 multiplied by x to the power of 1 times -5. So this is the same as 2 to the power of -5 times x to the power of -5. And then remember, when we interchange the numerator and denominator, the exponent becomes positive. So this is 1 over 2 to the power of 5 multiplied by 1 over x to the power of 5. And 2 to the power of 5 is 32. And this second part, 1 over x to the power of 5. So you can multiply the numerators. That is 1 times 1 is 1. And the denominator is 32, x to the power of 5. Right? So the third one is pretty much the same. Question 3 is pretty much the same as question 2. What you would do here is you would just indicate that the exponent for 3 is 1 and the exponent for x is 3, and then bring the exponent on the outside and multiply the ones on the inside. So that's how you raise a power to another power, by multiplying. So this should give us 3, 1 times 3 times x, 3 times 3. So 3 to the power of 3, and this is x to the power of 27. So that should give us 9 times x to the power of 27. 3 times 3 is 9, rectification, that should be 9, because 3 times 3 is 9, right? And then I want us to pay attention to question 4. What is important is that once you understand the fact that when an exponent is at the bottom and you bring it to the top, when you bring the power to the top, the sign of the exponent changes. So this becomes negative m. And the same could be said for instance, if you have a to the power of m, negative m, if you bring the exponent down, then it changes, the sign changes. So it becomes a to the power of m. The moment you bring the exponent down, the sign changes. If you invert the numerator and the denominator and there are powers involved, the sign of the exponent changes. So let's apply this concept. Let's apply this concept here to the problem we have here. Okay, so here we have 3x y squared, and we can see that the exponent here is negative. So the moment you bring this power to the numerator, then the sign of the exponent changes. So it becomes x to the power of 4. So already we can see that these two are like terms, so we can add their powers, or their exponents rather. So it will become 3x to the power of 1 plus 4 and y squared. So this is 3x to the power of 5 y squared. And lastly, I always insist that you write the exponents, even if they're not given. 5 to the power of 1 and y to the power of 1, all raised to the power of -2. So this essentially is a power raised to another power. And how to solve this type of a problem is by multiplying the exponents. So this is 5 to the power of 1 times -2 times y 1 times -2. Please don't forget, you multiply the exponents for all the powers inside the bracket. So what you essentially do is you bring this exponent in and you multiply, you bring him in there and you multiply. That's how I came to this. And then the denominator is simply 5y -2. So we can further write this as 5 raised to the power of -2 y raised to the power of -2 5 raised to the power of 1 and y raised to the power of -2. So when you bring these exponents to the numerator, their sign changes. When you bring these powers to the numerator, the sign of the exponent changes. So we can rewrite this whole expression, this whole term as follows. We can write this as 5 to the power of -2 times y to the power of -2 times 5 to the power of 1 times y to the power of -2. And these two are like terms, and these two are like terms. They have the same base, so you just add the exponents, right? So -2 plus 1 is 5 to the power of -2 plus 1, and y -2. Oh, I never changed the sign. The signs were not changed. So this is supposed to be +2 because I brought it up, and this was supposed to be -1. So now we can just add them. So it's 5 -2 plus -1 and y -2 plus 2. So this here is 0. So we are left with 5 to the power of -3, which is 1 over 5 to the power of 3, which is 1 over 125.